After several long years and hundreds of flight hours, I'm thrilled to announce we have received Flight into Known Icing certification from the FAA. By receiving the FAA certification, we established that the E1000GX can withstand known icing conditions in real-world operating environments with minimal changes required to the original design. This certification process is one of the most challenging, requiring proof of every FAA regulation. Through analysis, the use of computational and mathematical modeling, similarity, assessment of previously approved designs and systems, and the extensive testing, the actual recorded tunnel testing, simulated ice shape flight testing, and natural ice flight testing. In total, more than 450 hours on 3 test aircraft have been recorded, 195 artificial ice shapes, and 18 different icing configurations tested in several locations throughout the United States. Our journey began with tunnel testing to characterize the various ice shapes that grow on the wings in different conditions. The first tunnel we used was unable to represent all of the speeds and conditions we needed to prove. We then engaged the NASA icing tunnel to better characterize more accurate shapes. And right before testing was to begin, the pandemic hit. And the facility was closed for more than a year. Eventually, we were able to restart the tunnel testing. Each time a shape was identified, it was scanned into the computer so it could be 3D printed at our Bend, Oregon factory. Flight testing began with one small section of an ice shape placed on the airplane and flown to ensure safe flight. Another small section was added to each ensuing flight until the airplane was fully covered in ice shapes. We tufted the wings and recorded the effects of the ice shapes on the aerodynamics and the handling of the plane. That process alone took hundreds of flight hours and meticulous data collection. By completing artificial ice shapes first, we minimized the risk of entering actual icing conditions. We then instrumented the airplane, adding cameras inside the intake, wingtips, tail, inside looking out, and outside looking in. We sought out various icing conditions and monitored and measured the actual amount of ice and type of ice collected. At every step, we had to prove that the handling characteristics of the airplane were acceptable. The aircraft's design and systems already in place proved to be largely adequate for obtaining certification for flight into known icing. Only minor changes were required. The aircraft's de-icing boots on the wings were proven to perform in all required icing conditions. Unlike TKS systems, the boots work immediately after ice starts to form and don't require de-icing fluid, so no mess and nothing to fill or to run out of. The vortex generators on the leading edge were moved further away from the angle of attack sensor. We also added an additional heater around the sensor. Many aircraft have electrically heated windshields, which are prone to delamination, distortion, and potentially expensive repairs. Epic's bleed air protected windshield de-ices the windshield without requiring electrical power or filling of any kind of fluid. The inertial separator and inlet de-ice boot protect the engine during flight. The optical ice detector provides early detection for the presence of ice forming on the aircraft. All of these systems work together to provide a comprehensive and safe flight into known icing aircraft. I want to recognize the amazing talents and efforts of our flight test engineers and pilots that made this certification possible. We built this company to keep our planes, pilots, and passengers safe. We are and will continue to be the safest airplane in our class.